Alright, let's take a look at example 2. And for example 2, I'd like to dedicate this to period 2 because y'all have been really supportive of this project and I appreciate that. So this problem's all about y'all. So let's say that period 2 has 12 students in it. We could say that's our P0, that's our initial population. And it's increasing by 8% each year. So next year it's going to be a larger class, 8% by 8%. How can we model that? Well, let's do P2 of t would be our equation. And since P0 is 12, we'll write that there. And it's increasing by 8%, so remember the 8 is going to be written as a decimal, 0.08. So we have 1 plus 0.08 raised to the t power. Simple enough, y'all got this. Now example 3 is a little more challenging because we're going to have to actually make some predictions using a model. So we're given that 100 bacteria is put into a petri dish and it's doubling every hour. So first let's try to model this. So if we have, we'll just do P of t for population is equal to, our P0 would be what here? 100, so we write 100. And doubling every hour. So if it's doubling every hour, what rate could we put? Well, if you think about it, if after 1 hour, how would we double the 100 population? It would be 200. So to get from 100 to 200, we have to multiply it by 2. And since t is 1, then we want our rate plus 1 to equal 2. So our rate in this case is just going to be 1. So this would be our equation. Now we want the population, find out the time when the population is 350,000. So what would the 350,000, what could we replace with that? Well, the PT would be our population. So that would be 350,000. 1 plus, I'm going to simplify that to 2t. But how can we figure out how many hours does it take to reach 350,000? That's a little more difficult. Since we actually have t in the exponents, we can't just solve for t. Now, you'll learn later that we can actually use logs to get t by itself. But as for now, the best way to solve this problem is probably to graph it. If you graphed it, you would notice the y value of 350,000, the graph reaches it roughly when t is something like, we'll do approximately 11.77. So almost 12 hours, almost half a day for the population to reach 350,000, which, if you think of it, is not very long. Bacteria grows very rapidly.